Energy from the oceans is a technology being developed by the Department of Energy and the Solar Energy Research Institute. It is clean, round-the-clock electric power from a renewable resource. It is a potential resource that can save precious fossil fuels and supply large amounts of electricity to our energy-hungry nation.
Bob Douglas, manager of ocean systems for TRW, has been involved in the development of ocean energy technology since the early 70s.
I understand that the National Science Foundation brought industry into the study of ocean energy in the early 74, around in there.
In late 73 and early 74, the National Science Foundation recruited industry as industrial teams to study the technical feasibility of ocean thermal energy conversion systems. These studies were started in the spring of 74 and were completed in 75 by Lockheed and TRW and reported at the Offshore Technology Conference. Both companies and both industrial teams concluded that OTEC plants were not only technically feasible, that is, buildable from current technology, but that were probably could be economic within a relatively short development span. Plants that actually feeding probably island communities at first, which have the most desperate need for a replacement for foreign oil, notably Puerto Rico, the Virgin Islands, and the state of Hawaii.
The island strategy involves building commercial OTEC plants a few miles off major U.S. islands like Puerto Rico, the Virgin Islands, Hawaii, Guam, and Micronesia. The islands are forced to use more than 100,000 barrels of imported oil each day. For example, Puerto Rico spends as much as $1 million each day for oil to produce electricity. Because the necessary temperature difference is as close as 5 or 6 miles offshore from the islands, and plants can be as small as 100 million watts, the islands offer excellent early markets for the first OTEC plants.
OTEC systems can be economically sited virtually anywhere plus or minus 10 degrees of latitude. That is, at 10 degrees, anywhere from the equator, 10 degrees north or 10 degrees south. There are other locations which are attractive, particularly the Gulf of Mexico, which we believe could supply well over 50,000 megawatts of energy to the south coast of the United States. The Western Pacific would be an ideal location for the so-called plant ships. That is, the ships that might process ammonia or aluminum. The delta T, that is, temperature difference in the Western Pacific, is quite a bit higher than it is in the Atlantic.
This is a converted Navy barge, developed in a joint effort by the state of Hawaii, Lockheed Missiles and Space Company, and the Dillingham Corporation. It produces 50,000 watts of electricity, enough to power 12 average American homes, using no coal, no oil, just the vast ocean and the heat from the sun.
Just 15 months from the time Lockheed decided to build the mini OTEC and started the job, the system was turned on. Mini OTEC is the first net-powered floating ocean thermal energy conversion plant. Mini OTEC produced 50 kilowatts of gross power. To operate its own working equipment, provide necessary power for lights and other necessities for the operating crew, and still produced 10 kilowatts of net electrical power. This was within a small percentage of the Lockheed engineers' projections, and proved that ocean thermal energy conversion is a reliable and efficient method of producing electricity.
How tight does this focus? Can we see it?
Just look, yes. By spraying some water.
Oh my God. So if my hand's here, it's okay, but if it went there, what would happen?
Not at the focus. Here it's okay, but...
And even a mirror this big, would it be powerful enough to kind of set light to something?
Yes.
Can I try it?
Go ahead.
Okay, show me the focus. I'm okay, I'm okay, okay. Oh my life. Can we do that again? That's astonishing. I've never seen anything set light to wood that quickly. How hot is it in there? What temperature does it get to?
At that focal point, we can reach a temperature higher than 3,500 degrees C, and there is currently no known materials that could resist this.
There is nothing on Earth that can withstand the temperature right in the middle there.
Nothing.
And I'm pointing at it.
Exactly.
Just 2 square meters of sunshine can melt steel pretty easily. I would love to try and weld some stuff with sunshine. It'd be really nice. If you had 3 people sunbathing, they would be collecting that amount of sunshine. And look what it does. Despite having traveled 93 million miles, the energy of the sun can even melt rock. Look at that! You see, to me, that's far more amazing than melting steel. Like, I see steel melt every other day, but I've never seen anything like that.
In this project, we're trying to make good use of the sun for generation of bulk power. And we reflect the sun's rays using a parabolic dish onto the hot portion of a heat engine, and we use that collected heat then to turn the engine, and that in turn turns a generator and generates grid electricity. Your engine in your car is a heat engine. It basically takes heat and converts it to mechanical energy. In your car, we call it an internal combustion engine. In our case, it's an external combustion engine. We expand gases inside the engine, but we do it by applying heat externally. So we have an array of tubes that the sunlight is focused on, and that has a gas flowing through it, and that gas expands, and that moves the piston, which in turn turns the crankshaft. I've been working in concentrating solar power, mirror technology, for 20 years. We figured if we made a better heat engine, or a better receiver for that heat engine, the part that receives the energy and transfers it to the engine, that the right components would bring the right people together and somebody would make a system. Sterling Energy Systems has taken up an old technology from the early 80s, and they're modernizing that technology, putting some of our best technologies into that system and developing it into a commercial product. They are looking at bulk power generation, whereas in the past we've imagined dish systems would be used for remote or end-of-the-line grid applications with 1 or 2 dishes in a single facility. SES's approach is radically different in that they want to deploy as many as 20,000 dishes in one location. One of the keys to our success here is our collaboration with Sterling Energy Systems. No money is crossing the threshold. We are providing in-kind engineering services to SES, and they've put most of their engineering staff here on site in a technology incubator to learn about the hardware and to develop it in cooperation with Sandia. But SES is picking up the bulk of the finances for the system. They own the hardware and they pay their engineers. There's no contract in place. So it's an exciting way to do business. It's different than anything we've done before, but it looks like it's an effective way for technology transfer to occur.
John Kansas discovered that his radio frequency generator could release the oxygen and hydrogen from salt water and create an incredibly intense flame.
Just like that. If that was inside a car cylinder, you could see the amount of fire that would be in the cylinder. I can put my hand in here.
Put your hand into the beam, nothing happens. Put in a fluorescent bulb and it lights up immediately. At the APV Company Laboratory in Akron, top engineers have checked out John's amazing invention and they were amazed.
And we saw it go up to 1,500 degrees centigrade, the temperature. And it's incredible.
This simple Stirling engine is running with the heat generated by the flames coming off that test tube. The fuel, nothing more than salt water.
Well, that could be a steam engine, a steam turbine. Could be a car engine if you wanted it to be.
That's the true American innovator. Someone that is not looking for something, he just finds it.
This is the most abundant element in the world, water. And salt water is everywhere. And to see it burn actually gives me chills.
So imagine the possibilities. Salt water as the ultimate clean fuel, a happy byproduct of one man searching for a cure for cancer. In Erie, Pennsylvania, Mike O'Mara, Channel 3 News.
It looks like a desk lamp, is cool to the touch and appears to be doing nothing until it comes into contact with water. 92-year-old former Spitfire pilot Peter Davey claims his invention uses the power of sound to boil water.
DSIR, they're a bit baffled how it works. Nobody really knows how it works.
Davey believes high-frequency sonic vibrations emitted from within the silver bulb cause the water to boil. He says the idea came to him 50 years ago when he noticed different saxophone notes caused different household items to rattle. The mains-powered gizmo has experts intrigued.
Never seen anything like it in my life, as they say.
Professor Williamson has his doubts about Davey's acoustic theory and suspects there are two simple electrodes inside the boiler.
It's the conductivity of the water that provides the path for the current and provides the resistance to give the heating.
I'm careful that I don't divulge everything. I'm waiting to get a manufacturer that's prepared to put some money into it.
And if he does get it on the shelves, he's already got one interested customer.
If I saw one in a shop, I'd buy one, because I think they're an interesting little bit of technology, however it is they work.
When those bubbles burst, they burst with immense force against the object. As the speed of water increases further, the bubbles collapse with ever greater intensity. The process, slowed down nearly 100 times, reveals a long twisting thread emerging from the metal object. It is in this high-speed vortex of bubbles where the secret to the flood's incredible power lies.
So if you look at this, the first thing we see here is this very strong vortex here. So you got like a sledgehammer effect. Every time one of these forms and collapses, bang, you got a sledgehammer.